Hey guys, Mr. Marone here, welcome back in. Just got a quick video here for you to finish up our discussion on reflections. And up until this point, you've seen the reflection rules, where they had that capital R and then they gave you your line of reflection. Now we're going to work backwards. They've given us a pre-image in black and an image in red, and we've got to figure out what our line of reflection is that created this image. So the first step of this, which you guys see on your paper, is to write the coordinates of the pre-image and the image. So what I'm going to do is split my paper in half, and I'm going to write all of my coordinates for L prime, K prime, M prime on one side, and I'm going to write all my pre-image points on the other side. Go ahead and write that now. When I say write the points, I'm just looking at, like, L prime is at 3, 1. So L prime, and then I'm putting 3, 1. You're just going to write in those coordinate points. Go ahead and do that right now. All right, so now we've got our three sets of points for both our pre-image and our image. Now the next part is it says to find the midpoint of the segments connecting the two pairs of corresponding points. In other words, from L to L prime, what's the midpoint of that? From K to K prime, what's the midpoint? And from M to M prime, what are the midpoints? So for our midpoint of L prime, I'm going to add 1 plus 3 and divide by 2, and I'm going to do 3 plus 1 and divide by 2. So the midpoint of that is going to be 4 over 2, comma 4 over 2, or 2, 2. Okay, so that's going to be my midpoint of L prime. We're going to repeat that process with K prime, and with M prime. Go ahead and do that right now. All right, welcome back in. So we've got our 3 points. L prime is the midpoint of 2, 2 right here. That K prime is the point 1, 1 right here. And that my point for M prime is actually negative 3. I apologize for that. And even looking at that math, I see I've done it wrong, because negative 5 plus 1 is actually a negative 4. So I would have negative 2, negative 2. So there's my 3 points, and if I connect those lines, if I try, there's my line of reflection. So they're saying that the line of reflection is the perpendicular bisector of each of these segments. So we've got two options to approach here. We could find the slope of any one of those lines and try to find an equation for it, and then use our perpendicular knowledge to get there. Or we can use any two of the points that we just found and find our equation from there. So if I'm looking closely, if I want to find my equation of a line, I first need my slope, and the slope is found by seeing the change in y over the change in x. If I use L prime and K prime, I would have 2 minus 1 over 2 minus 1 for my slope. So my slope there is going to be 1. And then, as you guys remember, using point-slope form, using any of these points, I'm going to use 1, 1 because they're the easiest numbers. I'm going to do y minus 1 equals my slope of 1 times x minus 1, using point-slope form. And when I solve this out, I have y minus 1 equals 1x minus 1, and I'm going to add 1 to both sides, so I end up with y equals x. So that right there is my line. That's the line of reflection that's caused LKM to reflect onto L prime, K prime, M prime. So if we wanted to write our rule to finish this out, this right here, my reflection over the line y equals x of xy equals, and now we just want to look at what happened. So if we look closely from L to L prime, it looks like x and y just switch. And if we look at K and M, the same thing. It looks like we just reverse the order. So in order to do a reflection over the line y equals x, xy becomes yx. We just switch their locations, and that creates a perfect reflection over the line y equals x. Hopefully these steps are all right. If you have any questions, please go back to this, and please ask them in class tomorrow. Other than that, have a wonderful evening. Bye-bye.